present also work I did with my director Maria here, and Sarah, my co-advisor, and Bruno Biet, a professor in economics at HEC Paris. So I will not recall what a blockchain is. We have a set of maybe unbounded processes. We want to build a distributed ledger. We want it to be tamper resistant and to be built in an append-only manner. So basically, we want to have that structure. And one thing that we really want in this presentation is we want to keep the chain structure. Okay, so what are we doing? We are using consensus to decide at each block. So we want to have, at each point, each process to have a value, to decide a value, the next block, the agreement, any two processes should have exactly the same, and the validity, the blocks that are accepted should be valid. How that can be done, and how can we use consensus, basically? We can use committees. So we have the first block in the blockchain that is called the initialization block. That will select first a committee of fixed size that is known by the rest of the network. That process will run an instance of consensus and will produce the block. And they will send the information to the rest of the network. And with that selection and with the history of the blockchain, a new committee will be selected. That committee will do the exact same thing, and the committees are rewarded for what they are doing, basically. And those kind of blockchain exist. So, for instance, Tendermint, which someone already said a bit about, and also Hot Stuff that is published in PodC for this year. And we want to have a question, because if you remember the title of my presentation, you have rational in it. So we want to see what are the rational behavior, and if we do have rational participants in our committees, we can still guarantee the consensus properties. And here we will focus on determination and the validity. Okay? So this is the question we want this is the question we ask ourselves, and we want to solve it. But first, we need to have a model, right? And in our model, we have a set of order processes. I can say processes, player, agent, participant. All those words mean the exact same thing. The order is known by the rest of the processes, and that can be achieved. The messages are signed, and the signature cannot be forged. So processes cannot lie about the messages they create. We do have a synchronous communication, and messages cannot be lost. What I want to say by that is every process knows that during a certain time, they will receive all the messages. Okay, so even if you have an incorrect process that is trying to cheat, in our model we don't have those. Everyone will receive at the end of its time all the messages the others received also. That is important. And we are following the bar model, which was introduced in 2005, where bar means Byzantine, altruistic, and rational. What Byzantine is processes. Again, in that setting, Byzantine means the processes that want to hurt the system. Okay? The altruistic are the ones that are following the suggested protocol they are given, and the rational are the ones that want to optimize something, so to improve their gain. So staying in the system, but profiting from it. I will present you a small sketch of a protocol in this system model for correct, so for altruistic. You have a propose step where one player is selected as proposer. That player will propose a block and will send it to all the others. The others will receive and will check if that block is valid or not. And then if that block is valid, they will send a message for it. And after that, the other processes will just wait for receiving enough message for that block. So that means, for instance, if you have 4 processes, we want to have maybe three message for that block. And if they do receive that, the block is produced. Otherwise, they go to a propose phase again, where the next is the next process is selected as proposer. Okay? So just for example, we have 4 processes. We want to have three messages to validate the block. P1 is the proposer. P1 create a valid block, sends it to all the others. They receive, so they check the validity and the block is valid, so they send a message. P2, that's the same. P3 also, and P4 also. And the block is produced because we have 3 messages. Okay? And what we can see is that we do have a cost for, we can see that we have a cost, we can have a cost for each action. So we check a validity that costs us something. I don't know if you all agree. If someone disagrees, that person can raise their hand. And they are sending also a message. So they also have a cost of sending the message. CC means cost of checking, CS means cost of sending, and R is the reward because they produced a block. Okay? So this one is simple. We have the correct or altruistic behavior, and that is what we want to have. The block is produced, it is valid. Okay, so what we can do now is when putting the rational processes in the system is letting them decide if they want to pay the cost or not. So we just highlight 2 costs and we will talk about them. Okay? So for instance, at the beginning, when they receive a block, they can check the validity of the block. They can decide not to check and not paying the cost. Okay? And then once they check or not, they can either send or not send a message. If they send, they have the cost. If they don't, they do not. And what is important is if they don't check the validity of the block, they do not have the information about whether the block is valid or not, which seems also logical. Okay? We said that the Byzantines want to hurt the system, so the behavior, oops, I forget. Well, first, they I mixed. I can do it with the color. So we can assume that the green are the Byzantine, just for it now. They always check the validity. That is the most hurtful thing they can do. They always check. I should not do that. Just consider that they are correct. The correct behavior I explained is they check the validity, they send if the block is valid, and they do not send when the block is not valid. Okay? That is the correct thing. And then the red now is the Byzantine. And they check, also they always check in the system, but they do the inverse. So when the block is valid, they do not send, because if they did send, they are helping the system, and they want to hurt it. But if the block is non-valid, so not valid, they do send, such that maybe that block will get enough messages, and then the block will be produced, and then they will pay the cost. Okay? So this is the objective of rational processes. As I said, they can do whatever they want. They can do any behavior. They can have any behavior they want. They want to have the best with this formula, which basically means they do have a reward when they send a message for a block that gets produced. Okay, and they pay all the cost of the action they made. So if they send, they pay the cost of sending. If they check, they pay the cost of checking. And also they are getting punished if an invalid block is produced. So they are all getting punished. So I will explain a bit it later on. And we also have the assumption that the cost of sending is smaller than the cost of checking, which is smaller than the reward, which also is smaller than the cost of producing an invalid block. So again, an example. So we have, again, for processes, we still need three messages. P1 is the first proposer, send the valid message, check the validity and send. P2, well, all of them are rational. Okay? P2 checks the validity and send also. P3 does not check, but send. Why not? And P4 does not check and does not send. The block is produced, and we have that cost for each of them. Okay? Okay, now we have P1, which is Byzantine. Now. And P1 is the first proposer and send an invalid block. Sends it because it is Byzantine, and then he's paying the cost. He's not paying the cost, but that doesn't matter. P2 checks the validity, but still can send. I mean, it is rational, so maybe P2 thinks that it will be better for it to do it, and then the rest can do whatever they want, and then we have that cost. The invalid block is produced, so they are all paying the cost. Okay? So we have a concept of equilibrium, which is the perfect Bayesian equilibrium, which, as a presentation before said, it is a Nash equilibrium, but we also have a constraint where participants are learning from what happened. So basically what that means is we can have this behavior. So for instance, P2 and P3 check the validity, and then they noticed that the block is invalid, so that means that P1 is Byzantine, basically. And then now P2 is the proposer and just do the normal thing, and the block is produced and they pay the cost they have to pay. Okay? And they cannot do better than that, because if this one checks, I mean, it will pay the cost of checking also. If those one do not send, the block will not be produced. So if you recall, the question is, can we have the consensus properties? So just to go fast, and for the notation, we have n, which is the total number of processes. Nu is the minimum number of messages we want before the block get produced. And f is the number of Byzantine. And we assume that f is strictly bigger than 1, because otherwise it is trivial, let's say. So we have 3 equilibrium I will present. So the first one is if we have too many Byzantine, so more than the threshold, then the rational processes are always sending messages. So what happens is we always have termination, because at the first round, the block will be produced. But if the first proposer is Byzantine, then an invalid block will be produced. Okay? And they cannot do better if the number of Byzantine is bigger than the threshold number. The second equilibrium is, just to go fast and wrap it up, if we have less Byzantine than the threshold number, we have the first equilibrium which says that no rational is doing anything, so we do not have termination, but we have trivially the validity. And the last one, which is more complex, but says that we have a good equilibrium, but it is more complex to explain, where both conditions hold. So that's it. Thank you. And if you have any questions.